Can you receive amateur signals with a one transistor receiver? And I'm talking about a one transistor that feeds your headphones, not cheating with an external audio amplifier. Keep watching and I'll show you how. The secret lies in what's called a reflex circuit. One transistor is used for two functions. In this case, RF and audio amplification. It can be a little bit complicated, so I'll talk you through and hopefully you can better understand it. The basic receiver, first of all, is a direct conversion. It takes a little bit of RF from the local oscillator, which I'm using in the transmitter, mixes it with an incoming signal, and with the difference as audio, amplifies it to a level loud enough to be heard in the headphones. The local oscillator is part of the transmitter, so we don't need to worry about that. I did a previous video where I had a standalone receiver using the one transistor as the local oscillator and an audio amplifier. It sort of worked, but didn't produce enough gain. The benefit here is that because the local oscillator is being done by another transistor used in the transmitter, that frees up the transistor in the receiver to be used not only to amplify audio, but also RF, producing effectively a two transistor receiver. What you're seeing now is the circuit diagram for the transmitter. It's just two transistors. Now you could just use the single BD139 on its own and get maybe half a watt output, but I'm using it to drive a IRF 510 for around 5 watts. That bit of extra power is worthwhile, particularly if you're crystal controlled and your signal needs to be strong enough to draw other people to it and get them to reply to your calls. Anyway, if you want to learn more about that transmitter, then have a look at my 10-minute transmitter in a previous video. It's been very popular, so watch that video. I'll have a link below and that will tell you how the transmitter bit works. The important thing though to note is that the local oscillator is running continuously in that particular transmitter. I used that to provide a beat frequency oscillator for the National Panasonic transistor radio that I used. More on that in another video, and that was quite successful. However, the transistor radio was bulky, heavy, so I thought, why not build a receiver inside the same box, and then I wouldn't need to take the transistor radio. And so that brings us to today's project, the receiver. As you can see, just one transistor. How does it all work? I'll show you some still slides so you see it a little bit clearer. The incoming signal comes through here as a tuned circuit. It's a very simple tuned circuit. You don't need to wind any coils. That's because I use a pre-wound RF choke or inductor of 4.7 microhenry. That resonates with 100 picofarad in parallel on 7 megahertz. If you're building this version for 80 meters, then you could use a 10 microhenry coil and about 200, maybe 220 picofarad in parallel. That will resonate in the 3.5 megahertz band. We've got a bit of selectivity in the front end, which helps in case there are strong broadcast signals or signals on other frequencies that could overload it. Then a 10 picofarad capacitor. It is quite high impedance, so it's okay that you have a very small coupling capacitor. That also helps to suppress AM broadcast interference. That goes into our first transistor, just an ordinary transistor. I've used a BC548, and it's just connected as an amplifier circuitry. So a bit of voltage supplied to the collector, some bias provided by the 220k resistor, and it's amplified at the collector output. Now, there's quite a bit of circuitry around the collector. Ignore most of what you see for now, but the important thing as far as the RF goes is the 10 picofarad here, which feeds the RF into another tuned circuit, similar to the one that I described before, 100 picofarad, 4.7 microhenry, again providing a little bit of extra selectivity, which is important in very simple circuits like that. Then the output goes to a diode, a 1N60. It's a germanium diode, so the type that you use in crystal sets. It's important it is a germanium diode and not a silicon diode. But we also have, via this 10 picofarad capacitor, some RF. That's another source of RF, not the incoming signal, but this time from our local oscillator on 7 megahertz. You just need to change its frequency just a kilohertz off, and that is suitable for this receiver. Anyway, that comes from the one transistor in the transmitter, the crystal oscillator. So here at this diode junction, we've got a mixing of the incoming signal, RF, local oscillator, again RF, difference is an audio. Difference is only about 1 kilohertz, but it's a very low level audio signal. So if you were to connect headphones here, you wouldn't be able to hear it, it wouldn't be sensitive enough. Therefore, it goes through here, this extra capacitor here strips off any remaining RF, then it goes around back. You can see this extra wire down here, and feeds it back into our first transistor again. It goes via 100 nanofarad capacitor, 1 millihenry RF choke. I'll explain the reason for those later on. And this time we've got audio coming through this transistor, not RF, not radio frequency. And the transistor does exactly the same thing, but at audio frequencies. And that means that it functions as an amplifier. Now, with audio frequencies, because they're so low in frequency, that 10 picofarad here, it might as well not exist. It's insignificant for audio. 10 picofarad will pass RF, but not audio. However, we've got this RF choke here that's in series with a 33 microfarad electrolytic capacitor. Now, with a big inductor like this, a big inductor is the opposite of a very small capacitor. A very small capacitor will pass radio frequencies but not audio, whereas a big inductor will block radio frequencies but it will pass audio. So we've basically got circuitry here where you're separating RF to go this way and audio to go this way. And then it keeps going through here and then into our headphones. Now, I mentioned the inductors and capacitors passing RF and audio. Now, if we go back to earlier on, right here, you'll notice that the audio that I had feeding back was going via 100 nanofarad and 1 millihenry inductor. Again, that passes audio, but it's effectively a brick wall as far as radio frequency goes. Radio frequency just ignores the big inductor. Therefore, it doesn't interfere with the functioning of the circuit. So we've got one transistor doing two functions. It's amplifying radio frequency, getting it up to a bit stronger level for the diode, and then once the diode's finished with it, it's done the mixing with the signal from the local oscillator, feeds it back again, and the transistor works as an audio amplifier. So you've effectively got the transistor doing the job of two transistors, so then you can provide enough gain in the receiver for it to work with just one transistor. You could use a high impedance crystal earpiece. That's what's often used for, or used to be used for, QRP, very simple homebrew receivers. But I've found there's enough gain in this to power a lower impedance headphone or earphone. You know, something like 16 ohm or 32 ohm. The audio level isn't quite enough, but at least here I can hear band noise. I am in a fairly noisy location, but yeah, I can hear band noise and signals, and I can certainly understand people sending CW. If people were more than about 3,000 kilometers away, then you'd probably be struggling with those sorts of signals. But for people closer in, like up to 1,000 kilometers away, you should be able to hear quite strong signals in your headphone. And that's all done with one transistor in the receiver. It's magic. This circuit just works the transistor so hard that it does those two functions, and you get more gain than an ordinary circuit. Is this going to work? Will I actually get contacts with this? Remember, this is just 3 transistors, 2 in the transmitter, 1 in the receiver. It's just after 5 PM local, so it's a pretty good time for 40 metres. People are often just shooting around before tea. It's summer, so it's 2 or 3 hours before sunset, so it's before the DX and the interferences come in. So yeah, I think there's a reasonable chance of getting contacts, so I'll just call CQ and see what happens. It didn't take very many calls and I got a response for Merv VK3YE. He's in Ballarat, a distance of maybe 100, 120 kilometres, and I got a 529 report. I gave him a 569. There's a fair amount of local noise, and this is a very broad receiver, so in terms of selectivity, not the best receiver when you're trying to listen for signals in noisy or weak conditions. But did the job and was able to get a contact and hear people with this receiver. Here's a refined version using the same parts but on a smaller board and neater. The board is just a piece of printed circuit board. I haven't etched it, about 4 by 4 centimeters. There's a couple of pads that I've just glued on, and as for the external connections, not very many. You've basically got the headphones, antenna, BFO, power, and the ground. I think that's about it. I've now plugged in this external speaker so you can hear what this receiver sounds like. A thing I noted was the hash. It sounded a bit different to what you normally hear on HF. Almost like an FM radio. Something that's worth doing when you're experimenting with circuits is having a prod around with your fingers. Now when I touch the diode right here, that's breakthrough from a local AM station about 15 kilometres or so away. Another thing interesting I found was when I touched around the transistor, it's almost like you're tuning a receiver.
So, unfortunately, the human linger just for the actually to the eastern parts of the state. So it showers and thunderstorms this afternoon, central and eastern parts. Maximum temperatures in the mid-20s for the south, high 20 below north. That sounds like a beautiful song, doesn't it? The words you can't.
Now I've been able to select another AM station with some careful prodding.
Yes, good afternoon. I'm the first time caller. Oh, really?
Here's a case where one of the 10 picofarad capacitors was too small in value. I've got temporarily soldered across it an 18 picofarad. When I press here, that puts the 18 picofarad in circuit to give a total of 28 picofarad. That greatly improves the sensitivity. Here is the changed value from 10 to 33 picofarad. An unexpected bonus was when I flicked to transmit and press the key, you actually get a side tone. There's no separate side tone oscillator. It's just that things happen to be oscillating. There happens to be feedback created when it's in transmit, and you hear the noise. It's actually very, very loud. It's about 6:30, still a couple of hours before dark, so 40 metres should be quite good for up to maybe 1,000 kilometres. Just tuning around my crystal frequencies, nothing heard, so I'll put out some CQs with the improved receiver circuit and see if we get any responses. Now, just to prove that this works, we'll have a listen to my signal coming from the VK5 ARG with SDR. With the receiver mod done, performance was much better. With 2 contacts, one with VK7 and later with VK3. Still very broad, so this is really not a good receiver for DXing. If a station was to come up say 1 or 2 kilohertz away, unless you could zero beat them, they will probably interfere with the reception of your desired one. So this type of rig would be fine for casual operating during the day or in the early evening before the DX has come. And of course its 5 watt output is an attractive signal for people to find you if you're calling CQ. This has been our look at reflex receivers. The technique was much more popular with cheap AM broadcast receivers than with amateur radio construction. They're really from an era, basically the 1960s, when transistors were expensive and all effort was made to reduce the number of transistors and therefore the cost of price-sensitive equipment like transistor radios. Later, when transistors became cheaper, the need to reflex circuits became much less, so it's pretty much fallen out of use these days. Still, for the amateur constructor, it's an interesting novelty, and one that I hope has inspired you to try one. With this circuit, which should work on 40 meters with the value shown, or 80 meters with the key inductor and capacitor values doubled, you could add it onto an existing CW-QRP transmitter and get a receive capability with just one extra transistor. The volume in the headphones, especially if they're low impedance, is still somewhat low. If you've got an external amplified speaker, you can plug that in and that will give you sufficient volume. Still, it's amazing what you can do with a handful of parts. It is a bit tricky. As you saw before, you can get all sorts of interactions and feedback, but it's still an interesting novelty and fun to experiment with. So if you've tried reflex circuits, let me know in the comments below how you went.